Hello everyone. Today we're looking at graphs and functions, and in this section we'll be basically looking at various graphs and functions. Firstly, we start off by looking at parabola, and later on we'll look at straight lines, exponential graphs, hyperbola, and so forth. But let's quickly start off and explain what each of these coefficients kind of represent, but we'll get into the details in this section on how to draw these graphs. And I just want you to bear in mind as well that there are two mainly type of questions that they can ask you. The first one is where you are given the equation and then they ask you to draw how the graph will look like, and the next is where you're given actually the graph how it looks like and you need to draw, you need to derive the equation. But I just want to bring your attention to the value of c. C is basically the y value where the graph intercepts the y-axis, and a is said to be the gradient of this equation. But now we'll try to use the method of completing the square in writing this equation in a rather different way, and I'll let you know what after we have derived the equation by completing the square, what useful information will that equation give us. So remember what I said, when completing the square you want to achieve a value of 1 here. So if you're looking at this, we just factor out a so that we can achieve 1. So if you factor out a, we'll be left with 1, and here in order to compensate for the fact that we factored out a, we divide by a here so that it cancels at the end of the day. We don't lose the original structure of the equation. Likewise when it comes to c, right? Remember that the next step in the derivation of a different equation using completing the square, you need to add and then subtract half of the middle term's value and then square that. It's a specific process when you're actually completing the square. You must have 1 there, and then the next step you must add and then subtract half of the middle term squared, right? And then as you could see that we didn't lose the original value, we still have x squared plus b over ax plus c over a, because this actually just cancels out. But it helps us if we sort of structure this into rather two equations, and then we look at this. So if we structure this in this way, it's going to give us a rather more elegant expression. So if we simplify this, we have x squared plus b over ax plus half b over a squared, right? That's this part. And then next up we simplify this as well. So if we try to use a manipulation and then simplify this, we'll get this expression. On the other hand here, right, if we factorize this, we'll have x plus half b over a bracket x plus half b over a. I just want you to note, you could easily, since we have a plus and a plus here, it's easy to note that these are two brackets which will have a plus, and then since there's a 1 there, you know already you will have 1x on either side, and then here you'll just say the square root of 1 over 4 is a half. The square root of b over a is b over a, and then on both of these. But you can just if you want, try a longer way, or whatever way you know how to factorize. You'll see you'll get to this when you're trying to factorize this, right? And then thereafter a multiplication of these two will just be a square, and then thereafter I just distribute the a inside. If I distribute the a inside, I'll have this expression, whereas if I distribute there, the a will cancel out the square there, but we will still keep 4ac minus b squared, but now instead of 4a squared we will have 4a. I just want to bring your attention now to this. If we factor out -1, right, we will have b squared minus 4ac, right? And if you remember, this using the quadratic formula is a representation of delta, right? And so we write this now as like this. So it's that negative delta, right, over 4a. So that is negative delta. So we put in the negative delta over 4a. Now this is the new equation when we have expressed it in terms or rather by completing the square. This is quite a useful equation, especially when we look at how to draw parabolas moving forward, right? So again, I'm bringing your attention to the effect of A on this equation. Remember, this is the gradient, right? Since it's a gradient, the effect it has on the parabola shape is that when A is positive there, the parabola will have a smiley face. However, when it's negative, it will have the sad face, so to say. So next up, we further analyze the equation that we had on the previous page, right? This is what we have, right? I want you to know that whenever we have written the new expression by completing the square, the new term that's left on the outside represents the y value of the turning point, right? So what is the turning point? A parabola takes this form, right? Either this form. The turning point is basically this. And so this is basically the y value of the turning point, represented by q. So it's the y coordinate of the turning point. So that's what that represents. And I want you to also note that, for instance, if A is positive, right, this y value represents the minimum value that this parabola can have in whatever equation. Whereas when the graph is, or rather the gradient is negative, now the q value represents the maximum y value that the graph can have, right? And so now, in order to get the maximum y value, which is this, right, if we want to achieve the maximum y value, which is this, right, we do agree that this must go to 0, right? But we already if we want to achieve a maximum y value of this, right, this term must go to 0. But whereas we know that in a parabola A cannot be 0, right? So now we're left with one equation. The only equation that can be equal, that can allow the first term to go to 0 without actually making A equal to 0 is when this term is equal to 0. So x plus b over 2a equals 0. So when we solve, we get x equals to minus b over 2a, right? So x equals minus b over 2a is actually representative of the x value of the turning point, which is p, right? So do you notice that this is represents p, which is the x value of the turning point. So now we have two equations, right? The first one is q, and the next the first one is q, and the next one is for p, right? And we'll try to look at this now. Look at this, right? So we have this equation a x, right, minus b over 2a, bracket squared, minus delta over 4a. Remember, this is the same equation, because if you multiply this, you have a plus, and it's x plus b over a squared, which is the same as the above equation. So it did not lose structure, but what we want to have, we want to see how the p and q appear on the new equation. So now we see that this minus b over 2a is x, which is x value of the turning point, which is p. So instead of this, right, we substitute p, and this, I've said, it represents the y value of the turning point, which is q. So we write q, and in this is what you should remember. So when they ask you to write the equation of the turning point, rather, I'm not sure what other terms that they use for this. This is the equation you should have. And the nicest thing about this equation is whenever you see a parabola written in this equation, and then they ask you what are the x and the y value of the turning point, you could immediately see that whatever value appears there is the x value of the turning point. And then whatever value you're seeing here, it's the y value of the turning point. So basically this is for ease. Whenever we're using this equation is to help simplify rather our calculations, or rather make it easy for us to be able to draw the graph of the parabola. So now lastly but not least, we are looking at a method of sketching the parabola. This is a specific method. It's going to help you as well. So the first thing you need to identify is how your gradient is, right? Is it negative or positive? So if you know that it's positive, you already know that it will have a smiley face. Whereas if it's negative, you already know it will have a downward face. The next thing you need to do is you need to determine the y-intercept. Remember that we said that the y-intercept, rather, it's represented by the value c, right? And if you're not sure what that is, I don't like saying that it's represented by the value c. It's always best, right? Remember that if you have a parabola, right, at this point where the graph intercepts the y-axis, it's always x is 0 and we have a y value, right? So it's best that when you solve for the y-intercept, just on your equation, if you have y equals something, in terms of x, you need to just substitute. Whenever you see x, you need to substitute 0 and then solve for y, and that y value will be your y-intercept, right? And then the next thing you need to do is you need to determine what the x-intercept is. And as you could see, these are the x-intercepts for the parabola, and at these points we have a coordinates x and 0. At these coordinates we know y equals 0. So that's why whenever solving for the x-intercept, what you need to do, you need to set y equals 0. So when solving for the y-intercept, you need to set x equals 0. And one way to do that, after setting y equals to 0, you'll normally be left with an expression of the form ax squared plus bx plus c equals 0, which is a quadratic equation. And then what you need to do is you need to factorize in order to be able to know where the or rather what are the x and the two x's that make this graph equals to 0. So when you factorize, you will solve x equals p1, x equals p2, and then thereafter you should be able to know where these points are, because you know at these points your y values are equal to 0. And lastly but not least, you need to determine the coordinates of the turning point. This is specifically important because even though you know what these are, right? So now we've determined what the x-intercepts, we've determined what the y-intercept, but now we need to know what the coordinates of the turning point is. And one way to do that is either to remember that the x value of the turning point is minus b over 2a, and the y value is minus delta over 4a. And at times it might be easy to forget this equation, all right? But now this one is rather easy to remember. So if you solve what the x value is, you'll just say, and then you solve, maybe you find a value, specific value, and then you're going to take your y equation and then substitute whatever x you got there. Whatever x you got, you substitute, and then you get what that y value is, and then you can plug it in. And then thereafter, it should be easy to draw.